Problem 8. A group of people was surveyed about whether the council should collect recycling once a week instead of once a fortnight. 2/3 of the people said yes, and 1/3 said no. A year later, the same group of people was surveyed again, and this time 1/4 of them had changed their minds, resulting in a tie between the yes and no votes. Of the people who originally voted yes, what fraction changed their minds? So first, let's break this down, okay? So a group of people, how big is that group? So let's see. This only says stuff about what fraction instead of how many. Never said anything about how many. So can't we just pick some number? Well, we could, but we can't pick any number. Let's say something like 13 wouldn't work. What's 2/3 of 13? It said 2/3 of the people said yes. You can't do that. So let's choose something that has a lot of factors, and let's see if it works. Well, I did this, and the smallest number that worked was 24. So, oops, sorry. That's too big. 24. There's 24 people. So it says 2/3 said yes, so 16, and then the rest 1/3 said no. 16 yes, 8 no. And what else did it say? A year later, the same group of people was surveyed again, this time 1/4 of them, so 6 of them changed their minds. Let's write that down. 6 change their minds. And then what? Resulting in a tie between the yes and no votes. So a year later, it becomes 12 yes and 12 no. Okay, so it says 6 changed their minds, but you can change your mind from yes to no or no to yes. So let's see how we can write that in terms of variables, I guess. So 6 changed their minds, and then X of them. Let's suppose X of them changed from yes to no. Then the remaining 6 minus X changed from no to yes. So this is yes to no, this is no to yes. So it says that 16 yeses were at the beginning and then 12 yeses 1 year later. So let's write this down as an equation. 16 yes. And then X people changed from yes to no. So minus X people had yes as an answer. And then 6 minus X changed from no to yes. So you have to add that 6 minus X. And that's equal to 12. So subtract 12 from both sides. This becomes this. And then let's rewrite it. And then this 4 plus 6 becomes 10. And then the minus x becomes 2x. So 10 minus 2x equals 0. So x equals 5. So 5 people changed their minds from yes to no. Let's see what the question's asking for. Of the people who originally voted yes, so 16, what fraction changed their minds? So 5 of them changed from yes to no. So 5 over 16 is our answer. Okay, question 9. The vertices of a square are A, P, Q, B, R, S, C, U, V, and D, W, Z. The midpoints of the sides of the triangle are the points, and I think this is supposed to be square. The midpoints of the sides of the square are the points J, 9, 1, K, 12, 9, M, 14, 4, 12, and N, 1, 4. What is the value of P plus Q plus R plus S plus U plus V plus W plus Z? So I'm going to show you two methods of solving this. One, use the midpoint formula. The midpoint formula is just telling you that the coordinates of the midpoint are basically the averages of the coordinates of the endpoints. So like J, 9, 1 is equal to P plus R over 2. This is P, this is R. And Q plus S over 2. So P plus R equals 18. And then Q plus S equals 2. Yeah, let me write this better. And then use another line like this. This line will tell you that, well, 4, 12 is equal to U plus W over 2, U plus W over 2, comma, V plus Z over 2 by the midpoint theorem. So you get U plus V is 4 times 2, U plus W is 4 times 2 is 8, and V plus Z is 12 times 2, or 24. V plus Z equals 24. So, let's see. This is P plus Q plus R plus S plus U plus V plus W plus Z. And what is this? P, Q, R, S, U, V, W, Z. So why can't we add them up? So P plus R plus Q plus S plus U plus W plus V plus Z is equal to 18 plus 2, that's 20, 24 plus 8, that's 32, 20 plus 32 is 52. So, and we just got lucky again, PQRSUVWZ. This is also PQRSUVWZ. So, the answer is 52. Now, this is the second solution of problem 9. And this is pure magic. And this is also uses a lot of intuition, so I can't make it too rigorous, but this is a demonstration of how powerful intuition can be. So let's look at this diagram again. What would be the center of mass of NJKM? This. Well, it would be the center, right? Yeah, you know intuitively what the center is. So what if I told you that the center, the x-coordinate of the center would just be the x-coordinate of all the vertices, and the y-coordinate of the center would be the y-coordinate of all the vertices? Would you be surprised? Well, I wouldn't. This is an intuitive statement about the center of mass. It could totally be proven, especially in the case of a square, but this is just an intuition time. So let's just look at the intuition. Now let's look at the center of mass of this square. Do you see why it's the exact same point? Yes, right? And then how about the average of the x-coordinates of each of these vertices? Would that be the x-coordinate of the center of mass too? Yes. And the y-coordinate of each of these vertices? It would also be. So we have w plus, I should clear some space to make it more clear, w, which is this, plus u, which is this, plus r, which is this, and p, w, u plus r plus p over 4 is equal to x. And then z plus v plus s plus q over 4 equals y. But then what else equals x and y? Well, we see that we can also use the vertices of the other smaller square as an equation. 9 plus 12 plus 4 plus 1 over 4 equals x. And then the other, the y-coordinates, 1 plus 9 plus 12 plus 4 over 4 equals y. So let's calculate. 9 plus 12, 21. And then after that, plus 4 plus 1, which is 5. So you get 26. So x equals 26 over 4. Then, again, 1 plus 9 is 10. Then 12 plus 4, that's weird symbol over here, 26. So y is also equal to 26 over 4. So what happens if you add these two equations? You get w plus u plus r plus p plus z plus v plus s plus q equals, and divide by 4, equals x plus y. But what is x plus y? 26 over 4 plus 26 over 4, 52 over 4. So cancel these 4's in the denominator, and then we get this equals 52. Do you see what's so special about this? Yeah. If you don't know what it is p plus q plus r plus s plus u plus v plus w plus z. P, Q, R, S, U, V, W, Z. You see how magical this is? And we're instantly left with the answer of 52. Problem 10. The ratio of green balls to yellow balls in a bag is 3 to 7. When 9 balls of each color are removed, the ratio of green balls to yellow balls becomes 1 to 3. How many balls were originally in the bag? So, let's try some algebra. If the ratio of green to yellow is 3 to 7 initially, then they should have 3x and 7x respectively. When 9 are removed, it becomes 3x minus 9 and 7x minus. And what is the ratio between those two? It says 1 to 3. So 1 to 3. That means 3x minus 9 times 3 is equal to 7x minus 9. So 3x minus 9 times 3, let's expand it. This is equal to 9x minus 27. And then subtract 7x from both sides. You get this becomes 2x. And then add 27 to both sides. This becomes 18. So x equals 9. So initially there were 3x plus 7x equals 10x balls. So since we know x equals 9, 10x equals 90. Problem 11. The following 12 integers are written in ascending order. 1, x, 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 y, 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 8, 9, and 11. The mean of the 12 integers is 7. What is the median? So the mean of 12 integers is 7. Let's use that. The mean is the sum divided by the number of integers. So that's sum divided by 12. So sum is equal to 12 times 7, which is 84. And that's just 1 plus, there are 3 x's, so 3x. There are 5 y's. There's an 8, a 9, and an 11. So let's calculate this. Let's simplify. 9 plus 11 is 20. 1 plus 8 is 9. So this is 29. And then this 3x plus 5y, let's just keep it there. So this becomes 3x plus 5y plus 29. Then let's just subtract 29 from both sides. 84 minus 29 is 55. So we get 3x plus 5y is 55. 3x plus 5y equals 55. Now what? We need them to be integers. So let's see. This 5y is divisible by 5. Definitely. This 55 is divisible by 5. So this 3x must also be divisible by 5. So that means x must be divisible by 5. So 5, x is 5 or 10. But wait a minute. It says these numbers are written in ascending order. So 1 and then x and then y and then 8, 9, 11. But then x can't be 10. That's more than 8. So x has to be 5. So this becomes 15. Now this is just 40. 15 plus 40 is 55. So y equals 8. So what is the median? Well, let's see. 1. And then there's 5, 5, 5, 8, 8, 8, 8, 8, another 8, 9, and 11. What's the median? Well, there are 12 integers, so the median is the average of the 6th and 7th. So which one's the 6th? 1, 2, 3, 4, 5, 6. That's the 6th, and then the next one is the 7th. So the average of the 6th and 7th, which is just 8 and 8, is 8. Yeah, so that's the answer. Problem 12. Alex and Michael decide to meet at a restaurant between 12 p.m. and 1 p.m. Each will arrive at the restaurant at a random time uniformly distributed between 12 p.m. and 1 p.m. What is the probability that one will arrive at least 15 minutes earlier than the other? So let's first say why this is hard. Why? Well, think about it. Normally in probability or counting problems, there are a limited amount of choices you can make. But here, it isn't. Alex can come at like 1235.56, and Michael can come at like 1240.693434642. Yeah, so it isn't always discrete is what we call it. So it's not discrete, it's continuous. How do we describe that? Well, let's see. What else is continuous? Yeah, this is what I've drawn, a line. And if I write these, it should be clear what I'm gonna do. So this is for one person. Let's just say Alex. And then, how about Michael? Can we draw him on the same line? Yes, but it's not the easy way to solve this problem. So how about let's add another line for Michael? What do you think will be best? Yeah, let's suppose I add this. Would this be good? No. Okay, so you should see that the best choice is this line, perpendicular. Let's draw the square then. This is 1 p.m. for Michael. Now, how do we describe the equation? How do we describe the fact that one will arrive at least 15 minutes earlier than the other? Let's see. Let A be Alex's time, and then let M be Michael's time. One will arrive at least 15 minutes earlier than the other. That means the distance between their arrival time is more than 15 minutes. What is distance? Well, distance is the absolute value of A minus M. If you think about it, it should make sense. So A minus M is the distance, but it can be negative. What if Michael comes after Alex? It can be negative. So that's why we put an absolute value sign right there. And that's greater than or equal to 15. Now let's try to graph it here. So let's see. What do we do when we graph inequalities? Well, we graph the equalities and then we decide which side the inequality is on. So let's say A minus M is greater than or equal to 15, and don't forget to take the absolute value. So absolute value basically divides this into two cases. If A minus M is positive, it has to be greater than 15. If A minus M is negative, then it has to be less than negative 15. So let's graph each of those, except now let's make them equalities first. And remember, this is greater than equal to less than equal. So A minus M is equal to 15. This might be hard without the coordinate axes, but let's just think of specific times. Suppose Alex arrived at 12:15 and Michael arrived at 12 o'clock. That should work. So that corresponds to this point right here. And then Suppose Alex arrived at 12:30 and Michael arrived at 12:15. That should correspond to right here. Now, suppose Alex arrived at 12:45, Michael arrived at 12:30. That should correspond to this point right here. Well, it must be a straight line. Why? It's just a linear equation. A minus m. If you can think of it as x minus y, like the linear equations that you've been taught in school, then you can do it like that. You can say it's a line. Now, for the other equation, a minus m is equal to -15. Okay, let's do some more cases. I'll make it quick. Alex arrived at 12 o'clock. Michael arrived at 12:15. So that corresponds to this point right here. Alex arrived at 12:15 maybe. Michael arrived at 12:30. That corresponds to this point. And then Alex arrived at 12:30. Michael arrived at 12:45. That's this point right here. So you can make this into a line too. Now what? Well, what you do is, let's convert these into inequalities now. So suppose this was, instead of equal to, this first equation was greater than or equal to. Then let's just take one example point to see which side the shaded region should be on. So how about Alex arrived at 12:30 and Michael arrived at 12 o'clock? That satisfies this inequality. So if we plot that, that will be this point right here. So that's telling us that we're supposed to shade this region instead of the opposite one. Same thing, except now you reverse it for the other inequality. What if Alex arrived at 12 and Michael arrived at 12:30? That would correspond to this point right here. So we should shade this region of the inequality. Okay, now we've done this much. How can we find out the probability? So the way we did this, it ensures that these two shaded regions are what we want to find. How do we find them? Well, we just look at the area of these. We can think of this whole square as the whole probability set. So like Alex has to arrive between 12 and 1, and same with Michael. So this square, the probability that a point is in this square is 1, because they have to arrive at some time between 12 and 1. And then let's find the probabilities of the shaded regions. So remember, this is, let's clean this up a bit. Yeah. Okay. So now, if you remembered what I did, this was at the point 12:15. And then this was also at the point 12:15. That means this is length 15. And this is length 45. This is length 15, this is length 45. So let's label these two. These are also 45s. So to find the area of these two triangles, we just take 45 times 45 over 2 and then double it because there's two triangles. And then these two cancels out, so it's equal to 45 times 45. Let's just write it as 45 squared because there's going to be some simplifying later. So what's the total area of the square? That's just 60 on each side. So 60 squared. Now, to find the probability, we take their ratio, 45 squared to 60 squared. 45 squared is just equal to 3 squared times 15 squared, because 3 times 15 is 45. 60 squared is equal to 4 squared times 15 squared. So then their ratio will be, these 15s cancel, and it's just 3 squared over 4 squared. So look at the answer choices right here. Which one is it? Well, it's 9 over 16. So that's the answer. Problem 13. A cylindrical glass of inside diameter 6 centimeters and height 11 centimeters is filled and then tilted to a 45-degree angle so that some water overflows. How much water in milliliters is left in it? So here's this thing. And this might remind you of something. And by the way, this degree, 45 degrees, this will remind you of a right triangle, a right isosceles triangle. So, can we just use the formula for it? No, it's three-dimensional. But we can use an idea that we use to calculate the area of right isosceles triangles. So how do we even calculate it? Well, if you remember, the way to calculate the area of a right isosceles triangle is to draw the diagonal of a square. So these two right isosceles triangles are half the area of the square. So the area of a right isosceles triangle is 1/2 times its leg, this thing, squared. So can we use a similar idea on this? And it turns out we could. How? Let's make a square here by drawing this. This wouldn't be completely accurate. The real accurate thing is this. Yeah, so forget about what I just said, actually. I'll try it again. Yeah, this is it. And you notice that this is exactly half of the whole thing, of this whole cylinder. So how can we calculate the area of this? Well, we don't know the side length. We don't know the radius or the height. But then let's look at the problem again. Inside diameter 6 centimeters. So the diameter is 6, the radius is 3. Always work in terms of radius instead of diameter for those area problems and volume problems. So then this is also 3. Now we need to figure out the height. We know that this is 6 because the diameter, that's just the diameter. And then this whole thing is 11. So let's think about it again. This is a right triangle that's also isosceles. So this is also 6, and this is 5. So the rest of the calculation, let's just do it. 5 times 3 squared times pi. We're calculating the lower part of it first. And then plus 1/2 of, remember the 1/2, and then the higher part of it. 6 times 3 squared pi. So this is equal to 6 becomes 3. So 5 times 3 squared pi and 3 times 3 squared pi, that's just 8 times 3 squared pi. So this is 8 times 3 squared, that's 9. So 8 times 9 is 72. 72 pi. Yep, that's it. Problem 14. The 3-digit numbers C99, A6A, BC7, and B91 form an arithmetic sequence in this order. What is the value of A squared plus B squared plus C squared? So whenever you see a number theory problem where the variables don't seem to be so easy to find, don't try to find them using equations. So don't write stuff like 100C plus 99 and then whatever after that. So let's think about it in a more number theory way. And then here's another thing. It never said anything about this is an increasing arithmetic sequence, which is what I thought of when I did this at first. So let's look at the jumps. From 7 to 1, it's a jump of 4, right? And we're only looking at the units digit. From 8 to 7, it should be a jump of 4 too. Why? Because the common difference is the same. Or you can say the jumps are the same. So we already figured out one digit. For A to be 4 less than 7, well, A has to be 3. So 3, 6, 3. And now, let's look at the hundredths digit. So C99, 363, BC7, B91. Wait, it's curious how these two B's are the same. So what that means is BC7 and B91, they have the same hundredths digit, right? So they have to be less than 100 apart. You can't have like 3C7 and 391 be more than 100 apart. So that might give us a clue of what to choose. Now, let's look at what the digit C can be. Well, if C99 and 363 are less than 100 apart, C has to be 2 or 3. Well, let's analyze both of them. 299, 363. Well, let's see. So the common difference is 363 minus 299, which is 64. That's the common difference. So 363 plus 64 is 427. And then 427 plus 64 is 491. Well, look at that. C is 2, B is 4. We did it. And this C is also 2. But let's think about what happens in the other case. Well, you can say you're already done here, but it's good to check always. When you have time, that is. 399 and then 363. The common difference is 363 minus 399, which is negative 36. So let's do the subtraction. 363 minus 36 is 327, I think. Then 327 minus 36 is 291. So that doesn't work. Is B 3 or 2? B can't be both. So this one doesn't work. So this one's the answer. And to find the actual answer, we know that A is equal to 3. And then B is equal to 4. And then C is equal to 2. So 3 squared is 9, 4 squared is 16, 2 squared is 4, that's equal to 25 plus 4, which is 29.